All right, so I told you I was going to make a video about 2017 number 1 part D. Now, we had already gotten this volume function, and we're going to use the same kind of idea here, but when we go to write the volume out for this problem, we need to have a variable in that, because remember, they gave us dH dt, and we're trying to find dV over dt. Okay, but they give me this volume function, and if you think about this volume function, doesn't really have. What do we have here? Originally, we did this 0 to 10 of f of h dh. Well, there's no t involved here, so we need another way. Well, let's just go ahead. Let's go ahead and take the derivative of this. Well, when we take the derivative of this, we get dv over dt equals. And technically, I should rewrite this with a variable up here. I should put an h here, a 0 here, and put in like a dummy variable for now, right? Because basically, when I take the antiderivative of this, I'm just going to get f of h. But this isn't. Here's the problem with what I just wrote. This isn't dv over dt. This is dv over dh. Okay, but I want dv over dt. Now this is where I was getting a little bit confused. It's like, okay, well that doesn't make any sense. How do I go from dv over dh to dv over dt? Well, if you just think of this as a ratio here, isn't this the same thing as this? And this is what's going to be kind of funky. I could put the dv here, I could put the dt here, and I could put whatever I want here, including dh, since that's what I have, right? I can do that. I can just kind of separate that. And look, I have a dH over dt. They gave that to me. They told me in this problem that 0.26 feet per minute is the rate at which my height is increasing. So that's dH dt. So there's my dH dt. I'm going to plug that in for there. And I just found dV over dH. So the thing that I want to find is simply f of h dv over dh times dh dt 0.26. So let me write this out now with what we know. We now know that dv with respect to time, the change in volume with respect to time, is dv over dh, which we now know is simply the same thing as f of h, times dh dt, which we also know is the same thing as 0.26. Okay, they're specifically asking for it when h is 5, so I'm just going to plug in a 5 there. So what is dv dt when h equals 5? It is whatever f of 5 is times 0.26. F is this nasty function up here. If you type this whole thing into your calculator, hopefully you maybe you already did, because it'd make your life easier, as like your y1 or your f of x, then all you have to do is go to your table and type in a 5. And when I do that, I get that f of 5 is really about 6.517. Oops, that was supposed to be a times 0.26. So I get approximately 1.694. And that is the answer that they're looking for. Now, they do want us to have units here, which is pretty simple to do, because indicate units of measure. Well, what's going on here? Well, we're talking about a change in volume. Everything's been in feet, so this must be, if I'm talking about change in volume, this must be a cubic feet per, what was my time? It was minutes, so this must be cubic feet per minute. So basically, at that point, when this tank is 5 feet, you know, the water's filled like halfway, basically 5 feet up, it's filling at a rate of 1.694 cubic feet per minute. That's all there is to this one.